Hi students, it's Mrs. Schultze. I wanted to give you a video over the last assignment. So this was the assignment that you would have done right before our Easter break on Wednesday. Some of you did a really nice job on this and some of you seemed a little confused, so I wanted to clarify some things. Using the data that I provided for the seedling growth, you should have come up with a graph that looks something like this. Your time is on your x-axis and your height or distance would be on the y-axis. And if you notice, the dots or the data points that they gave us were a little all over the place. So we need to do something a little different than just connect each line. We want to do a line that's called the best fit line. So I'm going to actually run it through my origin down here, and I'm going to try and put some of the points above the line and some of the points below the line and get kind of what I'm going to call best fit line that runs through our data. So if you notice, I have some points above, some points below, but this is the approximate best fit for the data that we have. So that was what I was looking for in your graph. Now, the question in the box asked you to find out how would you use your graphed information to come up with the speed of the seedling growth. And so I've got down here a reminder of what speed is. It is a calculation of the distance over the time. And if you notice on our graph, we have the distance, it's in height, and our time in days. And so we actually have along this line a speed for our seedling growth. Now, some people have taken all the calculations and did an average of them, but if you did the graph, there's an easier way to find it. What I'm going to do is I'm going to kind of go along and I'm going to find a day where this one looks good. I'm going to find a time where it hits my line exactly on a line so that I know the exact height. It's not like 0.25, it's actually 3.5 here, and that is my day 4 time. So I could pick a point up here as long as it's like right on a day and right on a height. Just keeps it simple. So then I'm going to go ahead and use that X marks the spot to calculate speed. So I'm going to take my distance, and in this case that distance is 3.5 centimeters. So I'm going to put 3.5 centimeters as my distance, and then I'm going to look down, and my time for that spot was 4 days. So now I have the data that I need to finish my speed calculation. So I'm going to put into my calculator 3.5 divided by my 4 to get 0.875. And my units, I'm going to rewrite this. I'll show you in just a second. I'm just going to call it 87 centimeters per day. Or you could write it this way, 0.87 centimeters per day. And that's kind of like a speed that we would calculate for our car going 55 miles per hour or miles/hour. So when we're doing our speed calculations, we're going to keep both units and just kind of read it out that way. So here is the results that I was looking for on our run warm-up with our seedling growth. I hope this helps. You can email questions. We'll be doing one more little quick lab with this that I hope you guys enjoy. So please use this video to refer back to if you get stuck. Thanks.